Today we're working on section 5.4, properties of logarithms. Okay, so in the last section we got a taste for logarithms, we learned some concepts. We're just going to learn a few more properties in this section that'll help us with section 5.5. So we're not solving anything in this section, we're just working with the properties and getting used to them. So I have the three properties written down for us already. The first one, log base a of x times y equals log base a of x plus log base a of y. They're showing you how you can break apart your logarithms. So if you see multiplication inside here, you can split it up into different logs using plus. So if you see division, you can break it apart using subtraction. And this last one, if you've got a power, your number is to a power inside here, you can bring the power down in front of the log. So we're going to use all of these properties in our few examples that I'm going to show. In our first example, we're going to expand. So we're going to break apart the logs into sums and differences. So our first one, we see log base 9 of 9xy to the negative 3. Notice the y is the only variable that's to the negative third power. If there had been parentheses around the whole thing, then the whole thing would be to the negative third power. So pay attention to your parentheses. All right, so we see that we've got 9 times x times y. So we can break them apart using the first property. We're going to use addition and break them all apart. So they're all going to have log base 9 in front of them, and then we've got 9 plus log base 9 of x plus log base 9 of y to the negative 3. Then just see if there's any simplifying that you can do. In the last section, we learned that when these two numbers matched, it simplifies to just whatever the exponent is. And the exponent here is 1 because it's not written. We know there's a 1 there. Plus, there's nothing that we can simplify in this second part. So we've got log base 9 of x plus, and the last one, notice it's to the negative third power, so we can bring that power down in front like the third property told us. So we'll put negative 3 log base 9 of y. Okay, and that's as far as we can simplify. If you want to just put subtraction here instead of plus the negative, that's fine as well. Okay, so that's what you're doing in this section. You're just breaking it apart as far as you can, or in a little bit we're going to put it back together. Okay, so we're just practicing with our logarithms. Part B, they gave me log of 10 divided by the square root of x plus y. Okay, again, we want to break them apart. I see that we've got division in this one, so this one we're going to use the second property here, and we're going to break it up using subtraction. What is the base? Well, there's no base written. Remember, that means that it's base 10. Okay, it's just nice to keep in mind when we're finishing this problem up. Okay, so I'm going to break them apart. We've got log of 10. Notice the top is the one you put first. With subtraction, it matters which one comes first. So the top is always first. Minus log of the square root of x plus y. Okay, let's see if there's some simplifying that we can do. Well, we know it's base 10, so actually the base and the number right here match. So there's a 1 for the exponent again. So this one's just 1 minus log. Well, I can rewrite the square root as a power, remember. If it's the square root, that means the index is 2, right? And then inside there's no power written. Well, we know that it's the power of 1 then. The number on the inside goes on top, the index goes on bottom. So we can rewrite this as x plus y to the 1/2 power. And then we can bring the power down in front. Okay, so we've done a couple where we broke them apart. Now let's go ahead and bring them back together. Okay, so example 2. Condense. Or sometimes your directions will say write as a single logarithm. So you're going to bring it all back together so you just have one logarithm written. Okay, so part A. I've got log base 5 of x squared minus 25 minus log base 5 of x minus 5. Okay, well, before you bring them together, you should check a couple of things. Make sure that they're both the same base, of course. If they're not the same base, you can't put them together. Okay, in this section, they'll give you the same base because the whole point is to practice putting them together or breaking them apart. Okay, but check it out. They're both base 5. And then also make sure there's just a 1 in front of your log. Okay, if there's not just a 1 in front, what can you do with the number in front? You can bring it to the power, like we saw in our third property. Okay, so we don't have to do that in this one. There's 1s in front of the logs, but we'll see in the next one that we need to do that. Okay, so then we'll write log base 5, and that's the only time I'm going to write log base 5 because the whole point is to bring it together. And there was a subtraction sign in between, so that means when we bring them together, we're going to divide them. X squared minus 25 over x minus 5. Well, can I simplify it? We can factor the top. It's a difference of squares. So we've got log base 5 of x plus 5 times x minus 5 all over x minus 5. And then the x minus 5's cancel, so we're just left with log base 5 of x plus 5. Let's try one more. Part B. I've got 0.25 ln 81 plus ln 4. Okay, well, again, make sure they're the same base. Well, they're both the natural logarithm. What's the natural logarithm's base? Remember, it's base e. It's not important in this problem, but it's always nice to remember that. So when we run into it in the future, we'll remember. Okay, there's a number other than 1 in front of the natural logarithm, so we need to move that as the power before we can put them together. Well, we can simplify it a little bit before we bring them together. Remember, this power is just the power of the number here. Okay, so you can put it in your calculator, 81 to the 0.25 power. I already did that before I started, so I know that it's 3, but check it in your calculator, 81 to the 0.25 power. And then finally we can put them together. So we've got a addition sign in between them, so when we put them together we're going to multiply. 3 times 4 gives me 12. Okay, and that's where they want you to stop in this section because the whole point was to use the properties, not to use your calculator. So you can put the natural log of 12 in your calculator and get a decimal if you want to, but leaving it at this point is perfect. All right, if you have any questions, let me know.